All right. Let's get started. So, today we're going to talk about intro to derivatives. All right. When we were doing the difference quotient, all of that work took forever, right? It took forever. When we had the cube, it took forever. When we had the square, it also took forever. But what happens if you don't know? What if it's like to the 7th power? Are we going to be able to know how to do that? I mean, you will eventually, but it's going to be very, very hard. So in calculus, yes, we use the difference quotient to form a basis for something called a derivative. Before I get to the vocabulary and before we get to the examples and rules, I want us to look at some things, okay? So if we had f of x is equal to 22 minus 12x, that difference quotient was negative 12. If we had f of x is equal to, hold on, I'm looking at negative 5x squared plus 2x minus 40, that difference quotient was negative 10x plus 2. And for the cubed, sorry, I'm looking at your practice final. We had negative x cubed plus 7x squared minus 10x plus 15. This one took forever, right? And so did the fraction one. That says plus 15, guys. Okay? This difference quotient was negative 3x squared plus 14x minus 10. All right. When you're done writing these down, I want you to look at each of these terms. Okay? Terms meaning each of the things that are separated by an addition and subtraction sign. What I want you to do is yell out any patterns you see. So I have this pattern, right? Or this term. That belongs to this. What do you see? What do you notice? The x is gone. Okay? What about the 22? We can't have it both ways, man. It was freezing in here, and now it's warm. I am not going back to freezing. Wear less clothes when you come into my classroom. Anyway. What about between this and this? What pattern do you see between these two terms? 5 times 2 gives you what? Okay, and that's this one. What happens to the exponents? It's there. What is the understood exponent when there's no exponent? 1. So what happens to the exponent? It's okay if you can't see it there. Let's look at the next one. What is going on between these two terms? You multiply 3 times negative 1, and that gets you negative 3. What happens to the exponent? It goes down by what? By 1. What's happening to this exponent? Going down by 1. And how do we get 14? 7 times 2. This is the difference quotient, but we now have a rule for it. All right, let's start with our notes. Okay? We need some vocabulary. Before we get to the rule, you'll see what I mean. Derivative. Hold on. Give me a minute. Sorry. Okay. The derivative is the final equation after applying the difference quotient. So now I'm no longer going to call it the difference quotient. We're going to call it the derivative. Because we're not doing anything with the difference quotient, the new vocabulary word is derivative. We have some notation. Our first notation is d by dx. Am I going too fast? Okay. D by dx. What this means is they want you to find the derivative. For the final answer, we will also have notation. Just like when we were doing the tangent, we needed to do y equals, right? We needed to do y equals mx plus b. We needed to do m equals. We have some type of notation for almost everything in calculus. So your final answer, you also need correct notation. We have 3 different notations, okay? The first notation is dy by dx. dy by dx. What this means, can I go down? Everybody have derivative? What this means is that this is the derivative of y with respect to x. We're going to have some kind of like y equals. That's what that means. It's a derivative based on y, but we use x as the independent variable. Then we have f prime of x. This is going to be used for functions. F prime of x. Not f1 of x, not f dash of x. It's f prime of x. Prime. Okay? This means that this is the final answer for the derivative. Then last but not least, we're going to have y prime. Can you see that color? Yes or no? Again, these two things imply the final answer of the derivatives. You cannot go between equation notation and derivative notation or equation notation and function notation. It has to be whatever it tells you, okay? If it says g of x, you write function notation. If it has t equals, that is equation notation, which is this right here. Equation. Questions? Questions? Okay. Let me know when you're done so I can move on to the derivative rules. Oh yeah, sorry. Forgot it was past 10 minutes. Where does it say what? What's it say where? Where?
Next to the y prime.
Equation. Do you need me to scroll down so you can see, Ecker? Can I go? Okay. You guys are for real not going to last the day in the your seats that you want to sit in? All right, let's move on to the simple derivative rules. As a reminder, you will no longer be allowed to use your notes or review packets on your assessments. I told you this. You will, why? Because we need to pull away those helping things. You are seniors. I told you this at the beginning of the year. I told you this at the beginning of the quarter. What?
So like it's been like since the beginning of the year, the second semester is going to be like
Right. Now, I will still provide you with a formula sheet, so you don't have to memorize the formulas, okay? You just have to know how to use them, okay? All right. The constant rule. Does anybody know the definition of a constant in math? Not something that goes on forever. That is not the definition of a constant in math. This is sad. Nope. Nice try though. See, that would get you. What? The constant is a number without a variable. Constant is a number without a variable. Okay? So this rule is for constants. So, hold on a second. Okay, if I have to find the derivative of some constant, it doesn't matter if it's positive, negative, fraction, radical. As long as it is a constant, the derivative will always be 0. Always. Always, always, always. If it has no variable, the derivative is 0. Questions? Okay. The next rule is the rule that we will be using the most. It's called the power rule. The power rule is derived from the patterns we saw in the difference quotient. So if I'm looking for the derivative of ax to the n, where a is a coefficient and n is an exponent, the derivative rule is as follows. As Christian pointed out, and I don't know who else pointed out, we are multiplying the two things. We multiply the coefficient. Remember, the coefficient is the number in front of the variable. And we multiply the exponent. We multiply. And then, as Christian also pointed out, and other people, sorry, I don't remember who you are, my bad, you subtract 1 from the exponent. You multiply, you subtract. You multiply, you subtract. Okay? Questions? It'll probably make more sense when we actually do a problem. We need a few more rules, but these are not derivative rules. These are rules that we've had since freshman year, hopefully. What right now we're going to be using is the division rule for exponents. Am I off screen? So if I have x to the m over x to the n, does anybody know what I do to the exponents? No. Who said that? Yes, Emerson, subtract. You're going to subtract m and n. Okay? Can I go down? Everybody have the power rule or no?
Yeah.
So I can do that? And the other thing is just a little note to say if I have these things divided by one term, does anybody know what I can do to this fraction to make it easier? Anybody? It's okay if we don't. But make sure you know this. What we can do is we can split up the fraction and put both terms in the numerator into fractions. Okay? So I took the numerator, any term in the numerator, and divided it by the denominator. See? Do we see that? And then you can apply this rule. Yes, you're going to need these two rules for level 2, okay? This is just level 2. When you're done with that, take out the example sheet. You can either write the examples in your notebook or on the sheet, okay? Ooh, did I take attendance? I did not. I'm teaching, that's my job. Brian's not here, right? Are we good? No? Do you want me to zoom in? Zoom in? Kimberly? You sure? Okay. Oh. Are you guys done?
Yeah.
You sure? Adonis, you're done? All right, ladies and gentlemen. Number 1 is f of x is equal to x to the 7th minus 9x squared, and I'm not on screen, 9x squared plus 15. So remember, we're going to be using the power rule. The power rule says all I do is I multiply the coefficient and exponent and subtract 1 from the exponent.
Do we do this on the notes or the paper?
Thank you. I did say that, didn't I? Manuel, you okay? All right. What is my coefficient in my first term here? Huh? What is my coefficient here? 1. So, I'm going to start off by using the correct notation. Because I start with function notation, I have to end with function notation. All right. What do I do with 1 and 7? Multiply. What do I do with my exponent? No, I don't get rid of it. Subtract what? Am I going too fast? Okay. What do I do with 9 and 2? What does that give me? Oh, wait. I guess 9 times 2. What happens to the exponent? By? Okay. What is this called? What is a constant? Yes, Tiffany, I know it's 15. What is the derivative of any constant? 0. Christian, how do I know this is a constant? No variable. Very good. Questions? You cannot leave your problem like this. Simplify it as much as possible. If there are fractions, keep the fractions unless they can be simplified. No decimals, okay? All right, so this will give me 7x to the 6 minus 18x to the first. You do not need the 1, okay? Right now, I will not take off points for you writing the 1, but eventually I will, because that is not proper mathematical notation. Okay? Questions? Are we sure? I know some of you need processing time. I will give it to you. Are we good?
That's the answer?
Yeah, this is the final answer. That's the final answer. I can't hear you.
Why you do 7 minus 1?
Why did I do 7 minus 1? What does the rule tell me to do?
Subtract.
Subtract the exponent from 1. Or subtract 1 from the exponent. Okay? It's always like that. You always multiply and subtract 1. Multiply and subtract 1. Always. It doesn't matter how many terms we have. Right now, all we're doing is multiplying and subtracting 1. Okay?
Yeah.
Good? Jairo? I'm going to skip number 2 and I'm going to go to number 3. Because it's the same thing, just with fractions. And you know how to do it, Christian. Why is it that every time I take like a pause to breathe, we just keep talking? Class would go way faster if you would just be quiet while I'm giving lecture. Yeah. Okay. So, I need to find the derivative. I cannot find the derivative because I have multiple exponents in the numerator and denominator. So I have to use my law of exponents and subtract the exponents. So I have y equals 9 over 2. You want to keep the fraction by itself. X to the 7 minus 2. And I'm going to stop there and see if you have questions. That is a minus, not a dot. Are there any questions?
That's how you do it.
Yeah, I'm using the law of exponent.
They both have exponents. That's what you do?
Yes. If you have an x in the denominator and numerator, you have to use this for now because we don't know how to do it. I mean, I do. You don't. Okay. Any questions on this part? So all I'm doing is I'm using my law of exponents to simplify it so I can move on and take the derivative. You two need to be quiet. I can hear you whispering.
Tell me about the break.
Maybe I should just not let you two sit where you want. I don't know why you think it's funny. All right. So I've simplified. And in my years and years and years of teaching this, 90% of students, until they get used to it, will stop here and be like, oh, that's my answer. This is not your answer. This is not your answer. You haven't taken the derivative yet. You have not applied any derivative rules. All you did was simplify the problem to make it easier for you to use the derivative rules. Okay? Now we need to use the derivative rules. It is simplified as much as possible. So now I'm going to have dy dx. This will always be your numerator. Whatever it's equal to, if it's t, it will be t. This is always your variables in your equation. If it's s, this should be s. Okay? So pay attention to the variables, so this is correct notation. I have 9/2 times 5 x to the 5 minus 1. Why am I multiplying? Why am I multiplying specifically 9/2 and 5? Because it's the coefficient and the exponent, and that's what the rule says. Are there any questions so far? Okay, process. Yeah, the understood exponent when there's no exponent is 1. That's where that came from. Okay? What's 4? The exponent will be 4, yeah. So the final answer will be dy dx. Can you see that color? Multiply this, that gives me 45 over 2. X to the 4th plus 2. Yeah. You can also use y prime. That's fine. But you cannot use f prime of x because this is not a function, it's an equation. Okay? But Miss Santana, what happened to the x? Good question. This will become x to the 0. And what is anything to the 0 power?
0.
No, incorrect. We always say 0. It is 1, which means that this is just 2 times 1. So the x to the 0 cancels out. Questions? Questions? Are we sure?
So that's the answer, right?
This is the final answer, yes. Alright, if there are no questions, if you turn to the back, you have 4 problems. I'm going to put the answers up here, so this way you know if you did it right or wrong. But I'll be coming around and answering any questions you should be working, okay?
Yeah.
Does anybody need this still? Okay.